All right, so here we go. Welcome to Saturday Academy. We're going to do a review of the study guide number 5. You have study guide number 5 in front of you. For homework, you have study guides 2, 3, and 4. Okay? This one's going to replace one of those 3. So, however, for those of you that want the extra practice, you already have 3 more at home so that you can sit down with all your parents and your family. Oh, let's do a study guide. Yay! So, anywho, to get started, get that in front of you. We're going to start from number 1. Study guide number 5, problem number 1. And here we go. Can everybody see from back there? If not, you have it right in front of you, right? Okay, here we go. It says, name the property that is illustrated in the equation. For these, right away, the first thing you do, you write the variables or the numbers on one side of the equation. So this one is A, B, and C, and we write them without the operation. Is that correct? And then you rewrite the other side of the equation over here on the side in the same order. Let's see, it's B, A, and C, the way they are laid out. B, A, C, there it is. So now, do you see that the order changed from here to here? The order changed. C for change. The letter C for change will remind you of what property? Commutative. Commutative. Once you have that, you already know that it's property. Then you go back and look at what operation is being used throughout. Addition. So you just write of addition. That's simple. So therefore, if it changes, it's commutative. If it doesn't change, it's associative. Because then you'll see how the parentheses change from one to the other. Okay? Example number 2. Evaluate the expression for the given values of the variable. Don't rewrite this. What I want you to rewrite on your blank paper, you're going to write example 2. And we're going to rewrite this, but opening parentheses for all the variables. So we're going to write 2 parentheses squared plus 3, open a big parenthesis. And inside, we have a parenthesis for the letter R, minus a parenthesis for the letter T, over parentheses plus parentheses plus 2 parentheses. The reason that we open up parentheses so that when we do substitution, you don't make mistakes with the negatives and the positives if I ever give you negative values here. Everybody with me? So now let's substitute. It would help if you have your colored pen on Monday, so that when you're doing substitution, use a color for each variable so you don't get mixed up. That's a lot easier to substitute. So my letter R, I'm starting with red. R is inside of the parentheses, the very first one, so that is 5. And at the denominator, the very first number, it's also 5. From there, I'm going with green for the letter S. The letter S has the power exponent of 2, so that's 3. The letter S is also down here in the denominator, the middle term, that's 3. And with blue, I'm going to do the letter T. T is inside of the parentheses right here. This is 1. And in the denominator next to the 2, which is 1. Once you do all your substitution, make sure you write your order of operations, PEMDAS. Some of us like to skip steps or like to go a little bit faster. Slow your horses down, please. Like that, you can simplify all the numerator first, then from there, the denominator. Okay? Here we go. Let's start with the numerator. Do we have a parenthesis in the numerator? Yes, in here. So we're going to focus inside of the parentheses. So inside of the parentheses, do we have an exponent inside? How about multiplication and division? No. How about addition and subtraction? Yes. So therefore, from here, I'm going to rewrite everything. 2 times 3 squared plus 3. And what did we simplify this parentheses to? 4. So far, so good? So that was, we did inside of the parentheses. So now, I'm back again over here. Do I have an exponent? Yes, which is here. So therefore, this becomes 2 times what? Times what? 9, because I'm doing the exponent here. 3 times 3 is 9. I bring everything else over. I bring the plus, the 3, and the 4. So far, so good? Yes, Mr. Q. Good. So, from there, we're still working on our numerator till we have it completely simplified. Do we have multiplication and division in the numerator? Yes, multiplication here and here. So we get 2 times 9 is 18 plus 3 times 4 is 12. And the last step, do we have addition and subtraction in the numerator? Yes, so therefore this is 30. So far so good? We're done with the numerator. Can we simplify the numerator anymore? No. All right. Let's focus on the denominator. For the denominator, do I have a parenthesis? There's 3 of them, but I can't do anything else inside. Do I have an exponent? No. Multiplication or division? Yes, so I need to multiply this, so I rewrite everything. 5 plus 3 plus 2. I'm done with multiplication and division. Do I have addition and subtraction? Yes, so I go from left to right. So 5 plus 3, 8 plus 2, 10. Bring that over, bring that over. If we simplify, what do we have? 3. That's simple. As long as you do your substitution correctly, follow your order of operations, you will be fine. So make sure, slow down, okay? Okay, example number 3. Here we go. It says, 3 times a number is 9 more than twice the number. Find the number. So here we go. First thing that I want you to do is identify the word is. The word is. And we know that is a what? An equal sign, okay? So we're going to focus first on the first part. It says 3 times a number. How do we write that? 3x. Let's look at the last part after the is. 9 more, let's see, 9 more than twice a number. What is twice a number? 2x. What is 9 more than this? Plus 9. And then they say find the number. That tells you to solve it. So where do we start? The smallest variable, get it to the other side, right? Or get all variables to one side. So we subtract 2x, subtract 2x. We're left with x equals 9. In the semester final, I gave you guys one of these, and a lot of you froze, and it was that easy. All you have to do is one step to solve, and that's it. As long as you get the translation down, remember, start with the word is so you can get your equal sign, and then work on one side, work on the other, and then you'll be able to see it. Okay? All right? Any questions with this? Number 4. It says solve y minus 1 over 3 minus y plus 1 over 5 equals 2. So this one, since we don't have a fraction equal to another fraction, and we don't want to work with fractions throughout, let's get rid of the denominators. Therefore, we need to find our least common denominator, which is what? 3 times 5, that's 15. So we multiply everything times 15. Now, for those of us that get confused with the distribution, if this is a fraction, make 15 into a fraction, 15 over 1. So therefore, 15 multiplies the numerators, and the 1 multiplies the what? The denominators. Are we there? So, what do we have left? 15y minus 15 over 3. Before you do the next one, everybody pay attention, please. Pens down. Check this out. Remember what I told you about the negative. What do we need to do here? Distribute to these two terms. Everybody with me? If you don't, you're going to make a mistake. So check this out. This becomes a negative y, and this becomes a negative what? 1. Now we can multiply the 15. So what do we have? Negative 15y, negative 15. Does everybody see it? It was negative y, negative 1. We multiply the 15 here to both, so we're left with these two. Over, what is 1 times 5? 5. Equals 15 times 2, that is 30. And it's 30 over 1, we'll just leave it at 30. Let's simplify each fraction. 15y divided by 3, that's 5y. Negative 15 divided by 3, that's negative 5. Negative 15y divided by 5, that's negative 3y. Negative 15 divided by 5, that's negative 3, equals 30. Let's look at this. Can we simplify this side of the equation? Yes, combine like terms. We have 5y minus 3y. What does that give us? 2y. How about negative 5 and negative 3? Negative 8, and I bring down the equal to 30. From here, what do we do to solve? Add 8 to each side. We're left with 2y equals 38, and our last step, we divide by 2, y equals 19. So for this one, make a little note for yourself. Don't forget to distribute the negative. Don't forget to distribute that negative to both terms. Everybody see that? To here and here. Okay? Okay? Once again, don't forget to distribute the negative to these two. Are we there? Now, for those of you that were asking yourself, do we distribute it to the other? No, only to the numerator on the right. Right? All right. Get it? Right? No? Okay, number 5. Here we go. Any questions with this one? All right, here we go. Solve. Once again, to solve these multi-step equations, we need to get rid of parentheses, so we distribute. 6 times this, 6 times this, and over here 7 times this and 7 times this. So 6 times 5x, that's 30x. 6 times negative 4, that's negative 24. Bring down the equal sign. 7 times 4x, that's 28x. 7 times 5, that's 35. And I bring down the negative 19. Make a self note here. Bless you. Don't distribute to the number outside the parentheses. Because some of you do this. Everybody look up. Some of you, after you do 7 times these two, you also distribute to this one, and that's where you make a mistake. That number is not inside of the parentheses. Okay? So, let's continue. Can we simplify this side anymore, the left side? No. How about this side? Yes, we can combine like terms. What is 35 minus 19? 16. Very good. Bring everything else down. 30x minus 24 equals 28x. I'll leave it to you to finish from there. See if you can finish. Go. Okay, check your work with your neighbors, see what they did. If by now they're not awake, slap them, please. Just kidding, no slapping. Okay, so from this point, your neighbor said, we need to get all variables to one side. I start with the smallest variable, which is what? 28x. I subtract 28x from each side. We're left with 2x minus 24 equals 16. To solve, we need to isolate the variable, so I need to add 24 to each side. 2x equals 40. At the end, we divide by 2, because the 2 is multiplying. The inverse is to divide. 1 times x is x. 40 divided by 2 is 20. Hands if you got that by yourself. Okay, good. Go to number 6. Number 6. And once again, just a note. Make sure once you distribute, before you start solving, you distribute. Don't distribute to the number that's outside of the paren. Okay? All right, let's continue. Number 6. What percent of 40 is 2? For this one, as long as you get your proportion formula ready, you'll be fine. So you need to write is over of equals percent over 100. 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 Tell your neighbor the formula, please. Okay, so then from here you just write your blanks equals blank over 100. Start circling stuff. Let's see, of 40. I wonder where that goes. Denominator. The is, let's see, is 2. Where does that go? And they're asking for the percent. Since we don't know the percent, that's why we're going to write x for the percent. Cross multiply, we're left with 40x equals 200. Then at the end to solve for x, the 40 is multiplying, so we need to divide by 40. Divide by 40. 40 divided by 40 is 1 times x is x. Let's see, get rid of some zeros. 20 divided by 4 is 5%. Remember, don't forget to write your percentage, please. Bless you. Any questions with this one? Yes. If you see it, that's fine. If you don't, just go ahead and use the process. Number 7. All right, it says, solve. 2 times the absolute value of 5 minus 2n equals 6. When you get to these, as soon as you see this, the 2 brackets, do you see that the 2 brackets or the bars are absolute value? And check this out so that we remember this is a Roman numeral. 2 equations. So you can remember that the absolute value makes a Roman numeral 2. Is that correct? So you remember that you need to make 2 equations. However, first, we need to simplify. Simplify. So let's see, is there anything outside the absolute value? The 2, if it's in the front, on the left side, it's multiplying. So what is the inverse? Divide by 2. Divide by 2. We're left with absolute value, 5 minus 2n equals 3. Let's. So from there, do we have anything else outside of the absolute value here? No. We're done. So therefore, now we write our 2 equations. We're going to make one negative, so the 3 becomes a negative 3. We write whatever's inside of the the absolute value, which is 5 minus 2n. And we're going to make one equation that's for our positive. So this becomes, and for those of you that see it, the positive, it's always writing everything without the brackets. So it's 5 minus 2n equals 3. Does everybody see how this is the same as this, but without the absolute value bracket? Okay? And let's solve. Let's start with the 5. So let's see. The 5 is here. What is the sign of this 5? So what is the inverse? Minus 5. Minus 5. We're left with negative 2n equals negative 8. The negative 2 is multiplying, so we need to do division. Divide by negative 2, divided by negative 2, n equals 1. Oh, my bad. 4. Just wanted to check and see if you were awake. All right, here we go. So the 5 is a positive, and once again, we subtract 5, subtract 5. We're left with negative 2n equals to negative 2. At the end, we divide by negative 2, divide by negative 2, n equals 1. And we're done. Does it say to graph? No, for this one we don't graph. I just want the answers. So here they are. Any questions with this one? So make sure you have your note that you say 2 equations and you need to simplify first and leave the absolute value by itself. Okay? Number 8. Once again, what do you see here? Absolute value. So what does that tell you? 2 equations, but in this case, they're what? Inequalities. 2 inequalities. So therefore, let's simplify. Is there anything outside the absolute value? No. So we're going to make one negative. So the negative goes to the 3, so it's a negative 3. For inequalities, when we write our negative, what happens to the symbol? We switch it. We flip it over that way, and we write whatever is inside of the absolute value. 2p plus 5. Now that we have our negative, let's do one for our positive. We write everything exactly the same without the brackets, right? 2p plus 5 greater than or equal to 3. And let's solve. This one, subtract 5, subtract 5. 2p less than or equal to negative 8. And at the end, we divide by 2, divide by 2. P is less than or equal to negative 4. Look at this one. Minus 5 minus 5. 2p greater than or equal to negative 2. And at the end, we divide by 2, divide by 2. P is greater than or equal to negative 1. Are we there so far? Okay, on these guys, let's make a little note. Who remembers when we do inequalities that if we divide or multiply by a negative, we flip the symbol? Just remember when you're solving here, if at the end, look, everybody look up, please, pens down. If I would have had here a negative 2, what do I need to do? Divide by negative 2, right? What would I have to do here for the symbol if I divided by negative 2? You need to do what? Flip it. Same thing over here. Since we don't, we don't. But I'm just making a note so that you remember in case you get one of those. Everybody with me? All right. Are we done, let's see? Solve, but it says to do what? Graph. So let's get our number line down here. All right, here we go. So we got 0, We got negative. I'm going to start with this one. Negative 4 is about right here. Look at the inequality symbol. Does it have an equal sign underneath? Yes, so it includes the point. Plot your point. And it reads, P is less than negative 4. What numbers are less than negative 4? Negative 5 and anything to the left. Graph the other one. Negative 1 is about right here. Does it include the point? Yes, because it has the equal sign, so you plot your point. And it says, P is greater than negative 1. What numbers are greater? Everything to the right. Right? And of course, it includes 23. So, who notices that these two graphs are not intersecting here? That's why this is known as an OR. Okay, so for solutions, as long as you have this, I'm good. However, if you write your statement, the solution set, well, sorry, that's an ugly set. The solution set of all P such that what? What do we write? P is less than or equal to negative 4, or P is greater than or equal to negative 1. Remember that? Yay, we love these. We got it? Any questions with these? And once again, if you're saying, Mr. Q, do we have to write the statement? As long as you get me the answers and the graph correct, you're good up to right there. If you want to go the extra step and do this so that you can practice writing your statements, that's fine. Okay? Okay, let's go to number 9. Number 9. Number 9, solve and graph the inequality. Oops, this looks familiar, right? See if you can do that one by yourself, please. Go. All right, here we go. So for this one, who remembers that we need to do two inequalities? Yes, right? Okay. So we need to simplify to see if there's anything outside the absolute value. Is there anything outside the absolute value? No. So we get our two inequalities. One negative. So the 13 becomes a negative. If this becomes a negative, we flip the inequality symbol and write whatever's inside the absolute value. And if you did that, by now you should be able to do that step pretty clean. From there, you write our positive one. Everything the same. 2y plus 9 less than 13. And let's solve. Minus 9 minus 9. 2y greater than negative 22. Divide by 2. Divide by 2. Y is greater than negative 11. Minus 9 minus 9. 2y less than 4. Divide by 2, divide by 2. Y is less than 2. Hands if you got that. Okay? Now, the rest of the points are in the graph because it says to graph. If you didn't graph, you got some points off. So here we go. 0. I'm going to start with this one first. Negative 11 is right here. Does it include the negative 11? No, because it doesn't have the equal sign underneath, so we just mark our spot with a circle. We circle our spot, and it reads, y is greater than negative 11. What numbers are greater than negative 11? Everything to the right. Right? Graph this one. 2. Does it include the spot? No. And it says y is less than 2. What numbers are less than 2? Everything to the left. Do you see how they intersect here? That's why this is known as an and. So our solution is this one. So you need to write that and that with the graph. Or if you want to write the statement, is the set of all y such that, let's see, negative 11 is right here, 2 is over here, and does it include the 11? Does it include the 2? No, so we write y less than and less than. Remember that? That's the only one that we write like that, the and. Okay? Any questions with this one? All right, let's go to number 10. Number 10. All right, it says, if f of x equals x squared minus 3x, what is f of 0? Check this out, guys. Pens down, please. Pens down. Now, I'm going to go over this one so that we can clarify from this point forward, because I still have people, you guys are doing some funky stuff with these. Check this out. When we got to these, I said f of x, all it means is that it replaces the variable y. This is the same as y equals x squared minus 3x. But what it's saying is that it's a function. That's why they write it as function of x. That's why we write it as function of x equals x squared minus 3x. So if it's a function of x, that means x is here and here and here. So if they say f of 0, this becomes f of, instead of x, it's f of 0. So everywhere there's an x, what am I going to write? 0. So this is 0 squared minus 3 times 0. So what is 0 squared? And what is negative 3 times 0? So we write f of 0 equal to 0, f of 0 equal to 0. This is the solution. Copy that, please. We're going to go over it again. Let's see. All right. For those of you that are already done, let's use the same function, and I want you to find me what if f of, give me a number, okay, 5, f of 5. So let's do that one together. So what we need to do, we rewrite this, but instead of x's, what do we write? 5. So we write f of 5 equals 5 squared minus 3 times 5. F of 5 is, what is 5 squared? 25 minus 15. So f of 5 is what? 10. So far so good? Okay, let's do one more. The last one. I want you to use the same function, and I want you to evaluate when f of give me a number. 1. F of 1. Go. F of 1. Okay, you should be done by now. Check your work with your neighbor. F of 1, what they got. We got f of 1 equals to negative 2. That is correct. Okay? So far so good? Okay, let's do another one, number 11. 11. It says, give the domain and range of each relation. Once again, they're asking for the domain. So right away you're going to write D, then a bracket. Start with that one. Let's look at the x value. Let's see. We got 1, 2, 3, and 1. So my domain, I'm going to start with the smallest one, which is 1. From there it's 2. From there it's 3. And I'm done. We do not repeat. So you're going to make a note. Do not repeat numbers. Tell your neighbor what I just said. All right. Now let's look at the range. The range is all my y values. So we write R, bracket, get the y, 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 and y. And I'm going to start with the smallest number. What's my smallest number? Negative 3, which is this one. I'm done with that one. What's the next one? 5. Do I write it again? No. Tell your neighbor why. And then the last one is 7. That is right. We do not repeat the numbers. That's where we only write 1, 5. Okay? So, check this out. So the first part, it says, give the domain and range of each relation. So we're done with the first part. Some of you forget to read the rest. Tell whether the relation is a function. So let me show you the easiest way. You're going to write the domain like this. Remember those mapping diagrams? From there, I'm going to write my range. Okay? And let's map this. 1 to 5. 1 to 5. There it is. What's the next point? 2 to 5. 2 to 5. Next one, 3 to 7. 3 to 7. And the last one, 1 to negative 3. 1 to negative 3. By looking at it, does one of the x's have 2 different arrows? Yes, therefore this is not a function. Yes? No, it is a function. When one x has 2 different y's, that's not a function. It doesn't matter. We're focused on the x right now. Yes? Exactly. So, guys, and just so that we can remember when I use the example of the soda machine, that here goes the first person puts a quarter in because I sold the sodas for 23 cents, remember? My Q Fresh machine. And there goes Joel. He gets a Coke, presses the Coke button, gets a Coke. Everybody cool? From there, the next person goes, puts their coin in, and Priscilla presses Coke, and she gets a Dr. Thunder. So therefore, for the same button, she gets 2 different outputs. It is not a function. That's the same thing here. For the same one, there's 2 different outputs. That's why it's not a function. All right? Questions with this? So this is a 2-part, part 1 and part 2. Make sure you don't forget to read the entire question. Go to number 12. Number 12. It says, give the domain and range of the relation and tell whether the relation is a function. Once again, this is a 2-part question. They want us to write the domain. So right away, you're going to circle domain, and you're going to write domain. For these, remember, you write x less than or equal to, less than or equal to, and we need a number here and a number here. Remember those? So let's focus on the domain. You get your pencil. Let's do a vertical line test. So we start from left to right. Let's see. So we go this way. Wow. Where does it start? -3, and it goes, let's see, it goes through the entire graph, and the graph ends right there, which is what? 1. So the domain is from -3 to 1. Okay? Caution. Some of you would want to do this. Everybody look up, please. Pens down. Some of you do this. You say from -3 to 1, and you start writing -3, and you say, what's the next one? -2. The next one is -1, then 0, and then 1. This is wrong. Why? Because the graph, check this out, since it's connected all the way through, that means that if I place a point right here, what would be the x value? -2.5, won't it? That's why we include everything. Not only these numbers, but everything from -3 to -1. Okay? All right, with that said, let's find our range. For our range, we write y less than or equal to, less than or equal to. Remember, this and this never changes. This and this never changes. Tell your neighbor what I just said. So, for the range, we're going to get our pencil. Now we're going to do a horizontal test. We're going to start from the bottom to the top. From the bottom to the top. And let's scan this. Let's see. It barely starts right there. And what number of the variable? -2. And we scan all the way through, and it ends at what? 2. So my range is from -2 to 2. Are we there? All right. So we're done with part 1. The last part, is it a function? So check this out. Once again, you're going to get your pencil, do the vertical line test. Oh, wow. As soon as our pencil touches 2 different points on the graph, it is not a function. Is it a function? No, because it's touching here and here. How about right there? It's not a function because it's touching there and there. Not a function, not a function, not a function. So therefore, not a function. So once again, this is a 2-part question. Number 1, domain and range. And number 2, is it a function? No, not a function. Okay? Number 13. Here we go. Find the slope of the line described by 3x minus 6y equals 18. To find the slope, we need our equation to look like this. Y equals mx plus b. Remember this? In order for us to find out what the slope is, we need to rewrite our equation like this. We need to solve for y. Is that correct? And then once we solve for y, the coefficient of x will be our slope. So let's start. We need to leave y by itself. We need to get rid of the x. So what do? Subtract 3x. Very good. Subtract 3x. We're left with -6y equals -3x plus 18. And our last step. Divide by -6. Divide by -6. And we're left with y equals. What is -3 divided by -6? 1/2 x. What is 18 divided by -6? -3. But what are they asking for? The slope. So you need to make sure that at the end right here where they ask for the answer, you write m equals. So does this one look like this? Yeah, so my slope is next to the x is the coefficient. So what is my slope? 1/2. And we're done. Everybody see that? Let's do another one of these. Here we go. Label this one. This next one is 13Q. 13Q. Here it goes. Find me the slope of the next equation. There it is. Negative 3x minus 4y equals to negative 12. Negative 3x minus 4y equals negative 12. Find me the slope, please. Go. All right, let's see. Who did this? Add 3x, add 3x. We're left with negative 4y equals 3x minus 12. At the end, we divide by negative 4, divide by negative 4. So we're left with y equals, what is 3 divided by negative 4? It's negative 3/4 x. What is negative 12 divided by negative 4? That's positive 3. But what are they asking for? The slope. So my slope is the coefficient of x, which is negative 3/4. Hands, have you got that? Okay. Go to number 14. 14. It says, without graphing, tell whether the point 1, 1 is on the graph 7x plus 2y equals 9. For this one, we don't need to graph it. All we need to do is substitute the values into the equation. This one is x, and the next one is y, and all we have to do is substitute in here. So therefore, this becomes 7 parentheses plus 2 parentheses equals 9. So what is x? 1. What is y? 1. So let's see, what is 7 times 1? 7 plus 2 times 1, 2. What is 7 plus 2? 9. Is 9 equal to 9? So therefore, yes, on the graph. That's how you answer this question. I want to see the work, and I want you to see your statement. Everybody there? All right, let's try another one. I want you to try the point 2, 3. See if that's on that line. Yeah, use the same equation, but check and see if that point's on the line. Yeah, you substitute in here. Same equation. Let's see. So we rewrite the equation, 7 parentheses plus 2 parentheses equals 9. This is x. This is y. So what is x? 2. What is y? 3. Let's see. 7 times 2 is 14, plus 2 times 3 is 6. 14 plus 6 is 20. Is 20 equal to 9? No, so this one is not on graph. Of course, you have to show the work and then tell me the statement. Yes? What's that? Yeah, not on graph. Or online. Go to number 15. Here we go. 15. Find the x and y intercepts. Remember, for this one we use cover-up method. Remember that? So that we don't forget that if we're using cover-up method, we need to make 2 equations. One for the x. So check this out. If I was to cover the y value, what do you see? Negative 5x equals 10. So I got that, so I need to make also 1 equation for my y value. So now I cover the x. what do we see? What do we see? Negative y equals 10. Now we solve each equation. So what do we do here? Divide by negative 5, divide by negative 5. X equals negative 2. That's my x-intercept. If you write it as a coordinate, what's my coordinate? Negative 2, 0. Are we there? Look at this one. What's the coefficient of y? Negative 1. So therefore we need to divide by negative 1. Divide by negative 1. Y equals negative 10. So my coordinate is 0, negative 10. And those are my intercepts. Huh? That's all you, no, you, guys, pens down really quick. This is a mistake that some of us did last time. Check this out. Some of you did this. X value negative 2, Y value negative 10. This is incorrect. Because these are two different points, and you're telling me that it's 1 point. That's why I want you to do the X, and then write your coordinate, and then the Y, write your coordinate. Okay? All right. Let's take a quick 5-minute break. Everybody stand up, go outside, go to the restroom, and we'll be right back. Number 16. 16. Says, write in slope-intercept form equation. Write an equation slope-intercept form for the line through the given points 1, 3, and 3, 7. Part B, graph the equation using the y-intercept and the slope. And part C, write the slope of the line that is perpendicular to the given line. So on your blank sheet of paper, you're going to write 16. And then the very first thing that you write, since they don't give us the slope, you write your formula. M equals y2 minus y sub 1 over x sub 2 minus x sub 1. And the points that they give you, you need to label them. This is point 1, so this is x sub 1, y sub 1. This is point 2, so this is x sub 2, y sub 2. Now that we have our values, we know what to substitute in here. Is that correct? Before we substitute, I want you to do this. Right away, you do this, blank, minus, and minus. If you forget to put these two minuses, when you substitute negative numbers, you're going to make mistakes. Therefore, now we're ready to substitute. What is y sub 2? 7. What is y sub 1? 3. What is x sub 2? 3. What is x sub 1? 1. What is 7 minus 3? 4. 3 minus 1, 2. So my slope is 2. Are we there so far? Our slope is 2. Everybody see that? So now, we still need to get an equation, and our equation needs to look like this. Y equals mx plus b. So therefore, the next step, you need to write your slope, or your point slope form, which is y minus y sub 1 equals m times x minus x sub 1. So do we have those values? Let's see. What is m? 2. What is x sub 1? 1. What is, 1. What is y sub 1? 3. And you bring everything else down. Y, the minus, the equals, parentheses, x minus parentheses. All we have left to do is distribute and then solve for y. So let's distribute. 2 times x and 2 times negative 1. So this is 2x minus 2. I bring this down, y minus 3, and I solve for y. Plus 3 plus 3. Y equals 2x plus 1. does this equation look like this form? Yeah, so we're done. Part A is done. Yeah, part A. Part B, it says graph. Therefore, I'm going to make a coordinate plane. On your party, I am actually going to give you the graphing part so that you can just graph the equations. So here we go. I'll give you a coordinate plane there already. Well, let's graph this. Is that pretty straight? No. There it is. So, we need, it says here, use the y-intercept and the slope to graph. Let's look at our y-intercept. What is it? 1. So where's y1? It's about right here. So there's my point. And then let's use the slope to graph. What's my slope? 2, which is what? 2 over 1. So that tells me 2 steps up, 1 to the right. So from here we go 1, 2, and 1 to the right. Let's do it again. 1, 2, 1 to the right. Do it again. 1, 2, 1 to the right. And then you sketch your graph. Part B is done. So part A was to write an equation. Here it is. Part B was to graph. There it is. Part C, check this out. When you get to part C, they want us to find what? The slope. So right away you're going to write for part C, M equals. You're going to put a little box because you need to fill it in with a slope. However, look for the words either perpendicular or parallel. In this case, what is it? Perpendicular. So you're going to circle the word perpendicular and write the words reciprocal, inverse, or also known as opposite inverse. So let's see. What was our original slope? 2, and it's a positive. So therefore, our reciprocal inverse would be a negative. And if this is 2, what is the reciprocal? 1/2. And we're done with part C. Once again, for perpendicular, you don't need to show any work as long as you show me the slope that's reciprocal, inverse. Reciprocal inverse, opposite inverse. So check this out. What if our original slope over here was -3/2? What would be our reciprocal inverse? 2/3, and it's a positive because this is the opposite of a negative. Are we there? And the reciprocal is 2/3. Everybody with me? Okay. Go to number 17. 17. Solve the systems. Yay! Solve the systems of equations. So right away, we know it's a system of equations. So first things first, let's check it out. Are they in standard form? Let's see. Yes and yes. So therefore, our observation is in standard form. If they are in standard form, therefore we can use elimination. Elimination. So let's see. By looking at it, we have 2x plus 5y equals 11 and x plus 3y equals 7. Which one would be the easiest to eliminate? The x, because this one does not have a number. What number should be here in order to cancel the 2x and this one? -2. Therefore, we need to multiply this entire equation times -2. So therefore, -2 times x, that's -2x. -2 times 3, that's -6y. Equals -2 times 7, that's -14. So let's eliminate. 2x minus 2x, they cancel. What is 5y minus 6y? -1y equals 11 minus 14, -3. Let's solve. The negative 1 is multiplying, so we need to divide by negative 1. Divide by negative 1. Y equals 3. Are we done? No. Now we need to substitute into one of the two. Which one do you want to use? Top one. I always go with the first one so I don't mistake my steps. So 2x plus 5y equals 11. But instead of y, what do we write? 3. I bring everything else down. 2x plus 5 times 3 equals 11. 5 times 3, that's 15. I bring everything else down, and I solve. What do I do from there? Subtract 15, subtract 15. 2x equals 4. Oh, negative 4. Yeah, I was just testing it to see if you caught that. Divide by 2, divide by 2. X equals negative 2. And we're done? No. This is where some of you lost points last time. What is it says solve. That means they want us to solve the system. What is a solution to the system of equations? The point of intersection. What are my values? Negative 2, 3. Write solution. And write point of intersection. The solution to a system of equations is a point of intersection. Tell your neighbor what I just said. Number 18. Yay, the word problem. It says, Joan has $1.45 in dimes and nickels. She has a total of 20 coins. How many coins of each does she have? So right away, with word problem systems, we do 3 lines down, 1, 2, 3, 2 across. Remember those? Your favorite? So let's see. What do they talk about? They talk about dimes, so we write D for dimes. Or you can write dimes, that's fine. Nickels. And right here is total. So here we go. Let's start with our first setup. The first setup is going to be the value. The value. Okay? And the value we're going to write as decimals. Decimal. So how can we write a dime as a decimal? 0.10. Do we know how many dimes they have? No, that's why we write X. Or could we use the letter D better? Yeah, okay, let's use the letter D. Thank you. Yes. From there, how can we write nickels as a decimal? 0.05, and we're going to use the letter N for nickels. And what is the total value of the money? 1.45. This line, we're going to write the coin type. So let's see, what kind of coins did we have here for this column? Dimes. And do we know how many? No, so we write dimes. Do we know how many nickels? No, so we write N. But what is the total amount of coins? 20. Did I just write coins? Yeah, coin. Okay, there it is. All right, so check this out. So Joan has dimes plus nickels to give you a total. So we write our first equation. 0.10D plus 0.05N equals 1.45. The second equation is D plus N equals 20. Now that we have our system, we need to eliminate, since they're already in standard form, One of the variables, which one do you want to eliminate? The D or the N? The D. So therefore, guys, focus. So here, here, this is a positive 0.10. This one needs to be a negative 0.10. So we need to multiply the entire equation times negative 0.10. Let's distribute. This becomes negative 0.10D, negative 0.10N equals negative, let's see, what is 20 times 0.10? 0, 0, and then 0, 2, 0, 0, 2, 2 decimal places, so this is 2, or 2.0. All right, so now can we eliminate? Yes. 10 minus 10 eliminates. What is 0.05 minus 0.10? Negative 0.05n equals. You have $1.45, but you owe $2. How much more do you owe? Very good. 0.55. If you don't see it, you need to write them and do the subtraction. So, here we go. At the end, divide by negative 0.05, divide by negative 0.05. This is a 1, this is n. Let's find out how many nickels. So we got negative divided by negative equals a positive. Let me do my long division here, which you love. Yay, long division. How many times do I move the decimal over? 1, 2. So we're left with a 5. I move this over twice. 5 fits into 5 one time. 5 fits into 5 one time. So therefore, how many nickels? 11 nickels. So from there, I'm going to write my equation here that tells me how many type of coins of each. Dimes plus nickels equals 20. We know that there's 11 nickels. I bring everything else down and solve for D. Subtract 11, subtract 11. So how many dimes? 9. So, once again, we're still missing the last part. What is the last part? Statement. Joan has 9 dimes and 11 nickels for a total of $1.45 buckaroonies. 10 cubes. Number 19, here we go. It says, a plane can fly, yay, a plane, 3,750 miles in 3 hours with the wind. The plane takes 5 hours to travel the same distance flying against the wind. Find the rate of the plane in still air and the speed of the wind. So, once again, what is the key word here at the end? Rate. So then we write 3 lines down, 2 across, and this is a rate problem, so it's rate times time equals distance. So let's see, let's reread this. A plane can fly 3,750 miles, so we write that here, 3,750 miles with the wind. So we write with wind. How long does it take it? Or how long does it take for the trip with the wind? 3 hours. So now check this out. With wind is the same thing as tailwind. Tailwind, what does that mean? Does that increase or decrease your rate? Increase, so we write a plus. And what are we talking about? The plane and the wind. So we're going to write P plus W. Remember that? Yes. Say that again? If you write tailwind or with wind, I'll take either or, that's fine. As long as you understand what you're doing. So we're done with the first part. Then it says the plane takes 5 hours to travel the same distance against the wind. So let's write against wind. So, if it's against the wind, it's a what? Minus. So this is P minus W. How long did it take? 5 hours. And if it's the same distance, we write 3,750. Are we there? So let's see. Our formula is rate times time. So what is our rate for the first setup? P plus W times, to indicate the times is a parentheses, focus, times 3 equals 3,750. I want you to leave a couple of spaces here so that we can simplify. And let's write our second one. P minus W times 5 equals to 3,750. So now, let's simplify this one. What is the 3 doing? It's multiplying, so what is the inverse? Divide by 3, so we divide by 3. We're left with P plus W equals, let's see, do the division, 3,750 divided by 3, fits in here once, subtract, 0, bring down the 7, fits in here twice, 6, subtract, bring down the 5, it fits in here 5 times, 15, bring down the 0, it doesn't fit there anymore, so this is 1250. So far so good? So, this simplified to this, let's do the same to this one. Here we go. Divide by 5, divide by 5. We're left with P minus W equals, let's do the long division, 3,750 divided by 5. It doesn't fit here, but it fits here how many times? 7, that's 35. Subtract, that's 2. Bring down the 5. It's in there 5 times. That's 25. 0, bring down the 0, and it's 0. So this is 750. Are we there so far? Okay. So now I'm going to bring this one down here so that I can use my elimination method and solve it. So here we go. P plus W equals what? 1,250. Can I eliminate one of the variables from there? Yeah, the W. These cancel. We're left with 2P equals 2,000. Is that correct? Because we have this, right? And what is our last step? Divide by 2, divide by 2. So the plane speed was how much? 1,000 miles per hour? Wow. Man, that's pretty fast. Man, that's fast. All right. So, from there, which equation do you want to use to solve for the W? The plus, so this is P plus W equals 1250. But instead of P, we're going to write 1,000. We bring everything else down. So from there, we subtract 1,000. Subtract 1,000. W equals 250 miles per hour. Man, that's pretty fast. So, what is our statement? The plane's speed is 1,000 miles per hour, and the wind speed is 250 miles per hour. 10 cubed. Number 20. Shall we come back to 20 at the end? All right. Okay, let's go to number 21. What's that? What? Number 21? Yeah, let's do just number 20 right now, might as well. Okay. Here we go. Once again, 3 lines down, 2 across, and let's read this. It says, a chemist mixes 15% glucose solution with a 35 glucose solution to make a mixture that produces 35 liters of 19% glucose solution. So, let's see, this is the first one, this is the second one, this is a total. So we write first, second, total, and we write the percentages. What is the percent of the first one? 15%, 35%, and 19%. So our first line right here is going to be using the percentage for the glucose. So we're going to write glucose, and we're going to use percent, but we're going to use decimals. So, how can we write 15% as decimal? 0.15, do we know what that 0.15% came from? How many liters? No, so we write X. How about this one? 0.35 Y, and this one is 0.19, but this one we know that it came from how many liters? 35. So let's times that. 35 times 0.19, that's 45. We got 4, 27 plus 4, that's 31. 1 times 35, that's 35. 5, 6, 6, 2 decimal places, so this would be 6.65. Are we there? Okay. This one, we're going to write solution, but this is going to be in liters, right? Liters. Well, sorry. Liters. So let's see. Do we know how many liters went to the first solution? No. The second solution? No. How about the last, the total? How many? 35. So let's set up our equation. The first equation is 0.15x plus 0.35y equals to 6.65. Our second equation is x plus y equals 35. So, which one do you want to eliminate, the x or the y? X, so therefore we need to multiply the entire equation times what? Negative 0.15. So we're left with negative 0.15x, negative 0.15y equals to negative, let's see, 35 times 0.15, 25, we got 2, that's 17, 35, 5, 12, 5 2 decimal places. This is 5.25. All right, let's eliminate. This cancels this. What is 35 minus 15? 0.20y equals $6.65. Take away $5.25. We're left with 140. At the end, divide by 0.20, divide by 0.20. Y is equal to, let's see, 1.40 divided by 0.20. Move the decimal twice. 20 fits into 140 how many times? 7. So therefore, this is 7 liters. And we get our liter equation. Do you guys see this is the liter equation? And we write x plus y equals 35. So if y is 7, bring everything else down. X plus 7 equals 35. Minus 7 minus 7. X equals 28 liters. Our statement. Here we go. The chemist uses 21 liters of the, what percent? Oh, 28. Yeah, I did that on purpose to see if you were paying attention. 28 liters of the 15% glucose and 7 liters of the 35% glucose. Thank you. Is that correct? Yep. All right. All right. Somebody said to make it snappy. All right, let me see. There it is. All right, number 21. 21. For this one, you need your colored pencils, please. If you have your colored pen, you may use it. So, let's get a coordinate plane going. All right. So for this one, when you get to solving systems of inequalities, make a note for yourself. Need to be solved for y. So they need to be in y form. So let's see. Is this one already solved for y? Yes. How about this one? Yes. So now we're going to start with the first inequality in graphic. Okay, here we go. I'm going to use red. What's my y-intercept? 2. So I look at 2. 2 is about, let's see, 1, 2. It's about right here. Oh. All right, so we got our y-intercept. Focus, please. From there, we need the slope. What is my coefficient of x? -1. I'm gonna rewrite it like this, -1, so I can see it, and that's -1/1. That tells me to go down one step and one to the right. So I go down one and one to the right. Plot your point. Do it again. One down, one to the right. Plot another point. Do it again. One down, one to the right. Plot your other point. Now, let's graph our line. So let's look at it. Let's look at the inequality symbol. Does it have an equal sign? Does it have a little dash underneath? No. If it doesn't, our line should be a dashed line. Remember that? A dashed line. There it is. You want to use your other colored pencil to use as a kind of like a straight edge so that it's a straight line. And let's graph the region for the solution of that inequality. Let's see. If we look up, so for this inequality, I'm going to use the first part, which is y. I'm going to use the inequality symbol, which is less than, and I'm going to use my y-intercept, which is 2. So right now I'm on this line. Where's 2 at? Right here. And this says y is less than 2. On this y-axis, what numbers are less than 2? Everything down here. Is that correct? Therefore, with your light colored pencil, you're going to highlight or draw dashes of everything under this line. And those are solutions to that inequality. What's that? So far, so good? All right. Now that we got our light shade done, and when the day of the party, guys, on Monday, if you get to this problem on Monday, make sure you start with a lighter color, because usually when you start with a darker color and you do a light color afterwards, you're going to get like mixed up. But like that, you see where they intersect. Yes, you may use your pen. Yes. Yes, but if you have your pen, you can use your pen. All right, here we go. Let's graph the second one. I'm going to use blue for the second inequality. Same process. Let's see. What's my y-intercept? Does it have one? If it doesn't have one, notice there's something missing here, then we're going to write plus 0. So therefore, our y-intercept is right here at 0. There it is. What's our slope? 2, which is 2 over 1. That tells me to go up 2 steps and 1 to the right. So I go 1, 2, and 1 to the right. From there I do it again. 1, 2, and 1 to the right. From there I do it again. 1, 2, and 1 to the right. Look at the inequality symbol. Does it have a little dash underneath, an equal sign? Yes, so this one's going to be a solid line. A solid line. Yeah, that's why I'm using blue. All right. Now I'm going to graph this second inequality. What do I need again? I need the y, the inequality symbol, and my y-intercept. What was my y-intercept? 0. So let's read this. 0 is right here. Here's my y-axis. Y is greater than 0. What numbers are greater than 0? Everything up here. So with your darker color, you're going to shade. And here you can go the opposite way. You can go this way. All of this above the blue line. You guys see it? So hopefully now you are able to see where both shadings intersect. You guys see the both regions? So check this out. If you don't see it, make sure you box it in so that you can actually picture it. Here it goes. I'm going to make this a little bit thicker. Who sees that from here to there, to there, and everything this way is shaded by both colors? Does everybody see that? Okay, so we're going to label that solution set. Did everybody understand what we did? Now, why was it a solution set? Because check this out. If I was to pick a point from anywhere in here and I substitute it into both inequality, it's going to make each inequality true. Okay? Yes. Yeah, I'm already going to give you the graph on the party. All right, let's go to number 22. 22. Yay, polynomials. It says simplify, simplify. Here we go. Let's look at this one. Do we have an exponent outside of the parentheses? Yes, we need to distribute this exponent inside of the parentheses to each of the exponents. Remember, numbers or variables that do not have an exponent, write a number 1 so you won't forget to distribute. Does everybody see that? Look at this one. Which don't have an exponent? The 3 and the y. So you write a 1, you write a 1. And we're going to distribute this 2 to each of these exponents. So let's rewrite it. This becomes 2 to the what? Third, x to the 6, y to the 9 times 3 to the second, x to the 6, y to the second. Are we there? Okay, so once again, focus please. Notice that there's no addition and subtraction, it's all multiplication. So I'm going to start with the numbers first. I'm going to simplify the numbers. What is 2 cubed? That's 2 times 2 times 2, which is 8. Times. What is 3 squared? 3 times 3, which is 9. So what is 8 times 9? 72. So we're done with the numbers. So we're still multiplying now. Let's focus on the variables. What is x to the 6 times x to the 6? X to the 12. What is y to the 9 times y to the second? Y to the 11th, and we're done. So let's write a quick note for ourselves so we won't forget the steps. Number 1, distribute powers. So make sure you distribute this power inside. Second step, multiply numbers. And at the end, multiply variables. Does that make sense? Distribute the powers, multiply the numbers, and then multiply the variables. And that's how you simplify. Okay? Okay, one more? No. Number 23, Michael Jordan. That's right. 23. Here we go. It says multiply. Everybody look up, please. Does everybody see that there is no exponent here, but there is a monomial in front of this? That means we are going to distribute this whole thing for each term. For each term. So here we go. Negative 2xy squared times x cubed. Negative 2xy squared times x cubed. So check this out. Since there is no number here, the coefficient is what? 1. So what is 1 times negative 2? Negative 2. What is x times x cubed? X to the 4th. And do we have another y in here? No, I just carry the y to the 2nd. Remember these? Okay. Next, what is the coefficient here again? 1. So now it's a negative 1. Is that correct? Negative 2 times negative 1 is positive 2. X times x. X squared. Y squared times y squared. Y to the 4th. Now check this out. Pens down, please. This is where still some of you make mistakes. Here it goes. Look at this term and look at this term. They have the exact same variables except for the exponent. So that means we cannot combine this with this. At that point, we are done. Why? Because this one has x to the 4th, y second, and this is x to the 2nd, y 4th. Are they the same? No. Okay? Number 23 plus 1. Multiply 3x plus 10 to the 2nd power. We need to rewrite this first. This becomes 3x plus 10 times 3x plus 10. Now we use distributive property. Let's see. What is 3x times 3x? 9x squared. What is 3x times 10? 30x. Now we distribute the second term. 10 times 3x, that's 30x. 10 times 10, that's 100. Let's simplify. Can we combine like terms? Yes, these right here. What is 30x plus 30x? 60x. And then from there we just bring down the 9x squared and the 100, and we're done. No. Just negative 60. Okay? Number 25. Multiply. Okay, let's do this one together. 3y minus 2. Write that down, please. Times y plus 4. Once again, let's use distributive property. Let's start with the first term. 3y times y. 3y squared. 3y times 4. 12y. Go to the second term. Negative 2 times y. Negative 2y. Negative 2 times 4. Negative 8. Let's combine like terms. These two right here, what is 12y minus 2y? 10y. Bring everything else down, the 3y squared and the minus 8. And we're done. (26). Did everybody see what we did here? All we do is distribute and simplify by combining like terms. Yes? Sure. It's up to you. By the way, all these papers and all the scratch paper, the study guide, you're going to keep so you can use that as a guide at home. Once again, tonight I'm going to try and upload this hopefully by 7 or before 7. So like that, you guys can sit down. Instead of movie and a popcorn, you're going to have math and a popcorn, right? With your parents? Yes. What? Pretty much, yeah. Number 26. Simplify. Here we go. simplify. Cube root of 125, x to the 12, y to the 9. Cube root. What does that say? Everybody look up, please. This tells us, it's asking us what number times itself 3 times gives us 125. Let's see. For this, you start 1 times 1 times 1. No. 2 times 2 times 2. No. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. So therefore, the cube root of 125 is 5. So we got that done. Okay? Now let's focus on the variable. X to the 12. Look at the exponent. All we have to do is divide the exponent by the index. So what is 12 divided by 3? So this is x to the 4th. Therefore, y to the what? 3rd, because 9 divided by 3 is 3. And we're done. Let's do another one of these. Number 26 cubed. Write this down, please. Yes. 4th root of 16 x to the 20th, y to the 8th, and z to the 12th. Simplify that, please. 12. Oh, 8. Let's see. This says what number times itself 4 times is equal to 16. We do 1 times 1 times 1 times 1. No. 2 times 2 times 2 times 2. Yes. So it's 2. From there, x to the what? 20 divided by 4 is 5. Y to the 8 divided by 4 is 2. And z to the 12 divided by 4 is 3. Hands if you got that. Okay, that is correct. Remember, all we have to do is divide the exponent by the index. Okay? Let's go to number 27. 27. Factor completely. Everybody look up, please. When we get to this one, when you start seeing factor, the very first thing you're going to write is GCF. Write that note for yourself, please. From this point forward, whenever you see factoring, you're going to write GCF. Tell your neighbor, please. So let's see. What's our greatest common factor between here and here? A, and we're left with 9y squared minus 4. Everybody look up, please. What does this look like? It's a difference. Is it a binomial? Yes, let's see if it's a difference of squares. Let's see. Square root of this. 3y. What is square root of 4? Is it a difference? Yes, so therefore, 3y plus 2, 3y minus 2, and don't forget the BFF, which is a, and we're done. Yes. 9y squared. Let's do another one of these. Write this down. Example 27Q. Once again, factor completely. 32 x cubed minus, give me the number, 2x. 32x cubed minus 2x. Factor completely, please. You should be done by now. Okay, let's see. Factor completely, that means we're checking for GCF. What's GCF? 2x. What do we have left? 16x squared minus 1. If this is a subtraction and a binomial, let's check to see if it's a difference of squares. Square root of this, 4x. Square root of 1, 1. Is it a difference? Yes. So therefore this is 4x plus 1, 4x minus 1. Bring down the BFF. And this is factored completely. Anthony, got that? Okay. Move on to the next one. Number 28. Factor the expression completely. Tell your neighbor what to look for. GCF. Let's see. Focus, please. Do we have a variable that is in every term? Nope. Do we have a number that divides every term? No. Therefore, at that point, if we have 4 terms, can we group them? Yes, let's group these 2 and these 2. So, now, once again, now we're looking at it again, and we're going back to GCF. What is GCF of these 2? 5Q. What do we have left? 2Q minus 1. What's GCF for these 2? What's the same here and here? Plus 1T. I'm going to put the 1 here. Hold on, let me rewrite it because it looks kind of the same as my plus. One T. And what's left inside? 2Q minus 1. So, what's the same here and here? 2Q minus 1. And what's left for this term? 5Q. What's left for this term? 1P. And we're done. What? Sure. Number 29. Solve for x. Focus, please. Oh, for this one is solve for y. My bad. Solve for y. Since it's the y variable on this one. So, guys, focus, please. For this one, I want you to write 2 notes. Number 1, needs to be equal to 0. That's the first thing. And number 2, needs to be in what? Standard form. So those are the 2 things that we need here. So what do we have already on this side? We have 2y squared. Do you want to bring the 2y squared over to the other side, or these 2 to the other side? 2y squared to the other side. So how do we get that one out of here? Subtract 2y squared, subtract 2y squared. We're left with 0 equals negative 2y squared plus 25y plus 13. Let's see, is it in standard form? Yes. Okay, so let's start. Factor. Do we have a GCF? Yes. Leading coefficient is a negative, so my GCF is negative 1. Don't forget about that. If the leading coefficient has a negative and there's no number that divides, then therefore it's negative 1. What do we have left? 2y squared minus 25y minus 13. Now, we get our Power Rangers going. 2 times negative 13, that's negative 26. And underneath, negative 25. So factors of 26 that add up or subtract to 25, it's 26 times 1. But one of them is a negative. This tells me that the biggest one is a negative, so it's negative 26. Are we there so far? So now, this one we can open up 2 parentheses. I bring down the negative 1 equal to 0. But this I'm going to rewrite. What do I write? 2y squared. Is that correct? And instead of negative 25y, what do I write? Negative 26y, then plus 1y, and then at the end, minus 13. And now we can group. What's my GCF here? 2y, and we're left with y minus 13. What's our GCF here? 1, and we're left with y minus 13. So what's the same here and here? Y minus 13, and what's left? 2y plus 1. So to solve this, we need to set each factor equal to 0. So here we go. What is my first factor? Negative 1 equal to 0. What's my second factor? Y minus 13 equal to 0. What is my third factor? 2y plus 1 equal to 0. So, is this one true? No. That's why we do not use this one. But we solve these, don't we? So here, what do we do here? Plus 13 plus 13. Y equals 13. This one, subtract 1, subtract 1. 2y equals negative 1. And at the end, divide by 2, divide by 2. Y equals negative 1/2. And what are these called? Roots or zeros or my x-intercept. And we're done. Piece of cake. Number 30. Solve by completing the square. Yay! Once again, guys, when we're solving quadratics, what was the note that we just did earlier? They have to be equal to 0 and in standard form. So let's see. We already have the squared. We already have the n. We have the 210 here. So now check this out. Everybody look up, please. Pens down. When we get to these, to completing the square, look at the process. Step 1, standard form. No. Step 2, divide by the leading coefficient. What is the leading coefficient? 1. Step 3, eliminate the constant. So if this was over here, we should have sent it over here. So didn't they do already this, this, and this? So what is the next step? Step 4. Add b over 2 squared. So check this out. What is b? What is b? Negative 12. So therefore, n squared minus 12n plus negative 12 over 2 squared. Look at this step. What is it? Add b over 2 squared. What was b? Negative 12. What? Once again, didn't they already do all these steps? The equal to 0, standard form, divide by leading coefficient, eliminate the constant. Yes, that's why now we are here. They already did all those steps for us. Okay, let me backtrack. I see some of you that are looking at me like, you want to give me money? No? Okay. Here we go. I'm going to go through all the process. Here it goes. Let's make it into standard form. Minus 210 minus 210. We're left with n squared minus 12n minus 210 equal to 0. So is it equal to 0? Is it standard form? Okay, so let's begin. Divide by the leading coefficient. What is the leading coefficient? 1. Leading coefficient, 1. If we divide everything, it stays the same, doesn't it? Next step. Eliminate the constant. What is my constant? 210. So that means I add 210. I add 210. 210 to each side. We're left with n squared minus 12n. Leave a blank space equals to 210. Are we there so far? Don't we have the same thing that we started with? That's why I said we already skipped all these steps. Now we're here. Add b over 2 squared. What is b? Negative 12. So this is negative 12 divided by 2 squared. Add negative 12 divided by 2 squared. So let's see. What is negative 12 divided by 2? Negative 6. What is negative 6 squared? 36. I bring everything else down. N squared minus 12n plus 36. 210 plus 36. Step 5. Factor. Square root of this and square root of this. What is square root of this? And square root of this. And what is the middle? Minus. So this is to the second power. What is 210 plus 36? Are we there? Next step. Step 6, square root. So to cancel this squared, we do square root, where we're left with n minus 6 equals plus minus square root of 246. What is square root of 246? Is that a perfect square? What is it? Okay, they said 14. Let's see. 14 times 14, that's 4 times 4, that's 16. That's 5. 4, that's 196. Close. How about 16 times 16? 36. We got 3, that's 9. Plus 16. Oh, 9, 6, 5, and 1, that's 2. So therefore, it's not a perfect square. So, from here, all we have to do is solve for n. What do? Add 6, n equals 6 plus minus square root 246, and this will be your answer. We're done. When you cannot find a perfect square, if it's not a perfect square, you can leave it as a root form so that it's simplified up to right there. Yes? Number 31. Or do we do another one of these? No. Yes, let's do another one. Number 30. Q. Solve by completing square. Here we go. 2x squared plus 3x equals negative 1. So here we go. Step 1, make it equal to 0. So what do we do here? Plus 1 plus 1. We're left with 2x squared plus 3x plus 1 equal to 0. So let's start. Is it in standard form? Step 2. Divide by the leading coefficient. What's the leading coefficient? 2. So divide everything by 2. So we're left with x squared plus 3 over 2x plus 1/2 equals 0. Step 3. Eliminate constant. What do I do? Minus 1/2 minus 1/2. We're left with x squared plus 3/2 x blank equals negative 1/2. Step 4, add b over 2 squared. So what is b? 3/2 divided by 2, that means 3/2 times 1/2. That gives us what? Plus 3 over 4 squared. Plus 3 over 4 squared. So check this out. Square root, is that correct? So, no, my bad. This is factor, my bad. Factor. Square root of this, square root of this, squared equals, what is 3 squared? 9. What is 4 squared? Take away 1/2. So before I continue, let's subtract these two fractions. Can we make this one into 16? Times 8 times 8, so this becomes what? 8 over 16. So what is 9 minus 8? 1 over 16. Bring everything else down. X plus 3/4 squared. Let's get rid of that squared. Now we do the square root. Square root. This cancels this. X plus 3/4 equals, square root of 1 is 1. Square root of 16 is 4. And this is plus minus. And let's solve for x. What do we do? Minus 3/4 minus 3/4. We're left with x equals negative 3/4 plus minus 1/4. We do two equations. X equals negative 3/4 plus 1/4. And the other one is x equals negative 3/4 minus 1/4. So let's see, let's simplify. What is this? Negative 3 plus 1 is negative 2 over 4, which is what? Negative 1/2. What is negative 3, negative 1? Negative 4 over 4, which is negative 1. Roots. All right, let's go to number 31. All right, it says, write the value of the discriminant of the equation. So for part A, everybody look up, right on your paper. Part A, you're going to write b squared minus 4ac. That's the discriminant. Remember that from the quadratic formula? Okay. So, everybody look up, make a note. Standard form. Make sure that equation that they give you is in standard form. Is it in standard form? Yeah, it's already in standard form. So let's see. What is A? 2. What is B? Negative 10. What is C? Negative 6. Let's substitute. Negative 6 is here. A is 2. Bring down the negative 4. And B is negative 10 squared. Okay, let's simplify this. Negative 10 squared is what? 100. Negative times a positive. Negative times a negative. 4 times 2 is 8 times 6, that's 48. So therefore this is 148. This is A. That's the value of the discriminant. 148. Are we there? Part B. It says, use it to decide how many real roots of the equation. What kind of number is this? Positive? So therefore, if it's a positive, it's 2 roots. Remember that? So far so good? And letter C. Use a quadratic formula to solve the equation. Yay! So, let's write our quadratic formula. X equals minus B plus minus square root B squared minus 4AC over 2A. So, now that we have our quadratic formula, let's open parentheses, negative parentheses, plus minus square root over 2 parentheses. Everybody look up, please. Pens down. Check this out. For this one, so that you don't do all the work again, everybody look up. Didn't we do this part already? B squared minus 4AC. So what was it? So we're already right here at 148, and we substitute the values for B and A. What is B? Negative 10. And what is A? 2. So let's simplify this. X equals negative times a negative, positive 10 plus minus square root of 148 over 4. Since 148 is not a perfect square, I leave it like that. And we're done. Number 32. Here we go, 32. The height of an acorn falling out of the tree is h equals negative 16t squared plus 25, where h is the height and t is the time in seconds. Determine how long it takes the acorn to reach the ground. Look at the equation that they give us. They give us h equals negative 16t squared plus 25. To solve for the variable t, we need to make this equal to what? 0. So this becomes 0 equals negative 16t squared plus 25. Are we there so far? So, since we have a quadratic equation, in order to start factoring, what do we check for? GCF. So what's our GCF for these two terms? Negative 1. We're left with 16t squared minus 25. Bring down the equal to 0. Are we done factoring? No, look at this one. What does this look like? Let's see if it's a difference of squares. Square root of 16t squared, 4t, square root of 25. Is it a difference? Yeah, so this is 4t plus 5, 4t minus 5. Bring down the negative 1 equal to 0. Now we're ready to solve. Let's set each one equal to 0. So negative 1 equal to 0. I'm done with this one. Next one, 4t plus 5 equal to 0. And the next one is 4t minus 5 equal to 0. So let's solve. Is this one true? No, so we're done with this one. This one we subtract 5, 4t equals negative 5, and at the end we divide by 4, t equals negative 5 fourths. To the next one. Plus 5, 4t equals to 5. What's our last step? Divide by 4, t equals 5 fourths. Let's simplify this one. How many times does a 4 fit in here? 1, and we're left with 1/4, which is 0.25 seconds. Now check this out. I'm only going to use this one. Why? Because we do not count seconds in what? Negatives. We only go with our positive answer. Everybody see that? Okay. All right. Let's take a quick stretcher. Everybody stand up, please. Number 33. Divide. Look at this. We have addition and subtraction. Therefore, this looks like a binomial. So therefore, we need to factor. Factor the numerator. Open to parentheses. Power Ranger. Negative 54 and 3. Think about it. Factors of 54. Let's see. 9 times 6, that's 54. One of them has to be a negative, therefore, negative 6. So this is m plus 9, m minus 6. And what's our denominator? M minus 6. Do you see the giant 1? M plus 9. Hands if you got that by yourself. Okay. Number 34. Any questions with this? Should we do another one? 34. Here we go. Number 34, divide and simplify. 1m divided by m minus 6 over 6m. Guys, focus. We have two fractions dividing. Therefore, we need to rewrite it. First fraction stays the same, and we multiply times the reciprocal, which is 6m over m minus 6. Are we there so far? Okay. So now, can I simplify this fraction anymore? How about this one? No. So, we draw our line across. Okay. And let's identify our giant ones. You see our giant ones. What is it? M and M. So what is 1 times 6? 6 over m minus 6. Tell your neighbor why we cannot eliminate the 6 and the negative 6. Number 35, here we go. Focus, please. Simplify the rational. So step 1, we're going to simplify. But they also want us to identify our excluded value. So first, I'm going to do this. I'm going to find my excluded value. So I'm going to write EV. Remember these? I take my denominator and I make it equal to 0. Z cubed minus 3z squared, and all that equal to 0. Do we know how to solve these kind? Yes. What's our GCF? Z to the second. We're left with z minus 3 equals 0. From there, set each factor equal to 0. What's my first factor? Z squared equal to 0. What's my second factor? Z minus 3 equal to 0. Let's solve. This one, square root of this, square root of this. This cancels this. We're left with z equal to 0. This one, how do we solve? Add 3, z equals 3. So my excluded values are 0 and 3. What's another way of writing it? Z cannot be equal to 0 or 3. Either way, if you give me this or this, it's correct. That's one part. Now we need to do what? Simplify. Let's simplify. Look at the numerator. Let's simplify the numerator. Let's factor it. What's the GCF here? 4z. We're left with z cubed minus 3. Is that correct? Over. What's GCF here? Z squared. And we're left with z minus 3. This one doesn't have a square. Huh? I know, that's why it's z. All right. How can we factor this one? This is z times z. Is that correct? This one? Okay, so I already factored it here. Do you see the giant 1? What do we have left in the numerator? 4 times z cubed minus 3. What's in the denominator? Z times z minus 3. Do we do another giant 1 here? Why not? This one is a cube and this one is a 1. So we're done. So this is a two-part. First part, excluded values. Second part, simplify. Number 36. Here we go. Find the LCM. They give us two trinomials. Let's start with this first trinomial. We need to factor it. Do we have a GCF? No. We open two parentheses. Power Ranger. We got 10, 7. My factors are 5 and 2. D plus 5. D plus 2. We're done with this one. Focus on this one. Do we have a GCF? 4. And we're left with d squared plus 6d plus 5. Open two parentheses. Bring down the 4. We got a 5 here and a 6 here. What are my factors? 5 and 1. D plus 5. D plus 1. Get a Venn diagram. So what's the same here and here? D plus 5, that's our GCF. D plus 5. What's left on this one? D plus 2. What's left over here? 4 times D plus 1. Right? Here's the 4. Here's D plus 1. And to write our GCF, our LCM, we multiply everything that way. Where do I start? What do I write first? 4 times D plus 2 times D plus 5 times D plus 1. And that's our LCM. Okay. Now, before you get up, really quick, your homework. Remember, you have study guides 2, 3, and 4. The one we did today is going to replace one of those 3. You choose which one. However, if you want to do all of them, it's up to you, just to be ready for Monday. But remember, Monday is day 1 of the test, the party. Tuesday is day 2. So if you want to do 2 and 3 this weekend, leave number 4 for Monday night. Does that make sense? Yes? Okay? So with that said, okay, put those back where they belong. Here we go. All right, so once again, homework. You have study guides 2 all the way to 4. Number 5 that we did today replaces one of them. Is that correct? Okay. Therefore, have a good one, guys. Enjoy your weekend. I'll see you guys on Monday.